Assertion and reason. Assertion is during load flow study a voltage controlled bus is considered or treated as a load bus when the magnitude of voltage very much higher or very much lower than the scheduled voltage. So it is correct, where it is mostly depend on Q limit, means reactive power. If it's Q within the limit of Q minimum and Q maximum, then it is considered as a PV, or say not PV directly, it will considered as a generator bus. But this limits violates, then this voltage controlled bus is considered or say treated as load bus. So assertion is correct. Reason. Now reason is about tap changing transformer represented as pi network in load flow model. Reason is not match with the assertion, but if we say reason, a tap changing transformer is represented. If we say injected power frequency which represent in terms of network admittance Y matrix, because whatever we solve in the load flow system, we would use a Y bus matrix. So Y bus matrix is generally in terms of pi format, is like this. If I say YA, YB and YC, this is generally like a format of Y bus, which we can calculate Y bus directly, like YA plus YB minus YA minus YA plus YC. So that's why it is like a transformer tap changing representation, a tap changing transformer represented as pi network. So that's why reason is also correct, but the assertion and reason are not follow each other. So I hope you know about its option. The option is B. Okay, option 1 is assertion follow reason, option B is not follow reason, and both are correct. Next, in a power system, each bus and or node associated with a power 4 quantities: real power means P, reactive power Q, voltage magnitude means V, phase angle means delta. Now it is about load flow solution. Among the 4 quantities, number of specified quantities is, that is 2. I hope everyone know about it. I will draw again a table for that. If I say specified or say known and unknown and say known, and first I say load bus, then generator bus, then slack bus. For load bus, we known things are PQ, known things are PV, and remainings are unknown, means we can say PQ is known, then V and delta is unknown for load bus, and generator PV is known, then Q and delta are unknown. Now about slack bus, it is opposite of load bus. Whatever known, that is for load bus, that is unknown for slack bus. So we will write as a slack unknown is PQ and V delta is known. So option B is correct. This any two specified quantities like this: PQ, PV and V delta. Okay, next, Load frequency control is achieved by properly matching individual machines input. So here if I say load increase, then definitely rotor speed will decrease. Similarly vice versa, we say load decrease, speed increase, so it will affect the frequency also. Frequency will also decrease, frequency here increase now. So how we will manage? So only the turbine input which will bring back the original position. Okay, so turbine input will be here increase, and here turbine input will be decrease. Okay, so option C is correct. Other are like a reactive power. Reactive power cannot be to this frequency increasing. Generator voltage also can't able to do. Turbine and generator ratings can't do anything, so that's why only option C is correct. Turbine inputs will able to manage the frequency, which will increase or decrease its frequency depending on load. If it is increase, then turbine input will be need to increase. Means here if we say load is decrease, turbine input will also need to decrease. Next, if the voltage control bus is treated as a load bus, when which one of the following is limit will be violated? Here again voltage controlled bus, it is mainly limits are Q limits, Q minimum and Q maximum. Q means reactive power. Here reactive power option is C. Option C is correct. I hope you know about this point. Next, one again here, whenever this limits are not follow, limits means these are the limits, if it is not follow, then it will considered voltage control bus as load bus. Next, compared to Gauss-Seidel method, Newton-Raphson method text. Okay, I will write the differences one by one. Gauss-Seidel and here Newton-Raphson. First is it is simple, and it is here I can say sophisticated. Then we can say coordinates, rectangular coordinates here use rectangular coordinates. Here polar coordinates use. Time of iteration, time is less required, time is more required, and number of iterations, say iterations are more, here iterations are less. So from this two we can say the option, because option it is about only iteration and about time. Okay, this is time. So if we say compared to Gauss-Seidel method, Newton-Raphson method take number of iterations here is less, so we can say less number of iterations and more time is correct, option E. Okay, next, with the usual notation, impedance for a system shown here, a diagram is given, so we will easily not able to calculate Z matrix. Okay, this is given as a Z, impedance is given, so we will convert this diagram into a admittance. So I will draw in form of admittance. Now admittance of this 2 ohm is reciprocal is 0.5, then 1 is 1 and 2 is again 0.5. So this is YA, we can say YB, and this is YC. Okay, then I will write Y matrix as YA plus YB minus YA minus YA, YA plus YC. Then YA plus YB is 1 plus 0.5, then minus 1 minus 1, 1 plus 0.5, which gives you 1.5 minus 1 minus 1, 1.5. Now this is why we need to calculate, we have to in a form of y, in a form of z. So we will take inverse. For z we take inverse, means 1.5 into 1.5 minus 1 into 1, and here 1 as it is, signs are changes and here values are changes. Now we multiplied these things, which will gives you 1.5 into 1.5 is 2.25, 2.25 minus 1, and other terms are as it is 1.5. So this become 1.25, and then matrix 1.5 1 1 1.5. Now we can say 1.25 above, if we go, it will be 4 by 5, and inside is 2 3 by 2 1 1 3 by 2. Now go to the option, check which option is follow. So if we say even first term, if we write first term, it will become 4 is 6 by 5. Okay, 6 by 5, then 4 by 5, 4 by 5, 6 by 5. Option C is correct. I hope you understand these things, which is easier, and always need to consider a z. If whenever the z impedance, if it is diagram is in terms of impedances, we need to convert into y admittances, and then we can calculate y and then convert into z by taking inverse of y. Next, load flow study involve the solving the simultaneous equations. So the equation, I will write it first. Y P is equals to 1 upon y PP. Y PP means P is like 1 2 3 buses, so here P minus JQ upon VP minus summation of Y PQ and VQ. Here all terms are almost not differential. Okay, and this is also, we can't say linear. Linear means, I hope you understand, y is equal to x, this is linear. Non-linear means this is non-linear, like parabola. Now equation of this is like y equal to x. This is not a single equation like y equal to x or y equal to z, or like one linear. It is not looking linear, so we can say non-linear. We don't able to see any differential term, so we can say it is generally algebraic equation. So this is option B is correct. Next, a 12 bus system has 3 voltage control bus and dimension of Jacobian matrix. Again, Jacobian matrix is 2PQ plus PV. This is the formula. Now we will see generator bus. We divide into a like PV and slack bus. then write as a 1 as a fix. Then other terms we will write voltage control bus means PV. Nothing mentioned about violation of limits, that's why I write PV as a 3, slack as a 1. Then the remaining is load bus is PQ. Okay, load bus PQ is remaining means total, whatever the total is 12 minus 3 plus 1, which is 11. Okay, now Jacobian matrix is equal to 2PQ plus PV is equal to 2 into 11 plus PV is 3, means 20. Sorry, subtraction is, I did wrong. Subtraction is 12 minus 3 plus 1 means 8. Okay, 8. 2 into 8 plus PV is 3. Then 2 into 8 is 16 plus 3 is 19. So 19 into 19 is option C is correct. Here we will mistake here mostly in the subtraction or considering about the slack bus and in PV bus. Also sometimes in the violation of limits we consider PV as PQ. That is also mistakes happen here. Also mistake happened in multiplication here, 2 into something, this like 8, 2 into 8 is 16 plus 3. Here calculation mistake will happen and options are generally nearby. This is like 21, 19. So that's why nearby options, that's why we take this calculation very seriously here. Next, principal information obtained load flow study in power system are magnitude and phase angle of a voltage at each bus means V and say delta. Then second option is about reactive and real power P and Q. Third option is about total power losses, so we can say PL. And transient stability of a limit, so we have to select the correct code. So we can't say transient stability here, we don't take transient stability, which we cannot obtain from the load flow study. From load flow studies, which is mainly like a GS method, NR method and fast decoupled method. All these are around P, Q, V, delta, and this all gives you about losses. Okay, so only option 1, 2, 3 are means these lines are correct, so option C is correct. Okay, I hope you got this information correctly, understandably. Next, Y bus matrix of 100 bus system which have 90% of sparse. Now we have formula of this transmission line. We have to calculate number of transmission line, so we have formula of transmission line is equals to 1 minus sparse. It is in percentage, means percentage means value, you have to write value here, into n square minus n upon 2. N is we can say total bus. Okay, total bus. Here n is 100. So, and sparse, percentage sparse is 0.9, that is 90%. Okay, so I will write as 1 minus 0.9 into 100 square minus 100 upon 2, which is like 0.1 into 100 into 100 is 10,000 minus 100 upon 2. This will give you 1000 minus 100 upon 2, which is 900 by 2, which gives you 450. So option A is correct here. Next, match the list. In first is about load flow methods and second is system environment. So there very here important C is start with the Gauss-Seidel method. I will write how it is started the load flow study. Actually, load flow studies start with Gauss-Seidel, and then coming some its limitations come, so we have to eliminate. So to eliminate this, there are some limitations, which means we can say Gauss limitations, which eliminate by Newton-Raphson method. And then these methods improved by Gauss-Seidel, say fast decoupled method. So here we check first. Here in Newton-Raphson we take more time. Okay, that is the limit, that is limitation for Newton-Raphson. So we have to eliminate that time by in this fast decoupled we use LU means lower and say upper triangular matrices. Lower upper triangular means this is like this. If I say 9 terms in a matrix, so these 3 are lower lower triangular, and these below 1 2 3 are upper triangular matrices. So that will become 0. One of them become 0 in each of them. So we have more sparsity in the network, so calculation will be easier and fast. So we can check the option now. Say first fast decoupled is related with LU factor. Okay, Newton-Raphson is about elimination of Gauss-Seidel. Okay, then about third real time, and we can check the option first. B is 1 and 1 here, and then C option is about 2, so this is 2 only in the C. Then the remaining A will match with 4. A means 4 is offline solution with a Gauss. So and the next one is last real time load flow, which we make contingency studies. Contingency means we will, as per the situation, we will changes the parameters. So option C is correct here. I hope you just remember about this, how system is started with the Gauss, then how we will go with the Newton, and then why we will go upgraded with a fast decoupled. So the option will, we can match this pairs. Next we have bus admittance matrix of power system given here. The impedances in a given, we have to calculate y, say z impedance of Z23 is what. So we have given y, so we have to y23. Now 23 is always come as small y23. Check in the 2 and 3, which is this term J10 minus J10. We take a reciprocal of this, like Z23 equal to 1 upon y23 equal to 1 upon minus J10, which will give you J.1. So option E is correct here. I hope you understand why we take a reciprocal and the value of it. So the option E is correct here. Take care of this thing, because in a Y matrix of diagonal element means these are diagonal elements which we can consider as a positive and other terms are negative, so that's why y2 3 come here. So we have taken it as a negative. This is just the admittance matrix. So first, initially its matrix will be, means whenever it will form, it won't be like this, it will be like, I write as just like a 50, J30 and J25, and then we can say J10. So these terms all are negative. J5 minus J10 minus J10 minus J5 minus J10. So this is the first, means whenever the system form, I don't write it y, whenever the system form, this will given, and then we will multiply by the negative sign, so it will be this, the whatever the given is, this matrix is formed. So if you multiply negative sign to this matrix, it will be negative sign multiplied to non-diagonal, means negative sign you have to multiply, not we can say diagonal only, but to consider this thing, this is the term. That's why we are mostly confusing between this term only. Okay, always take care of this thing. Next, in a network shown, marked parameter are per unit impedances. So this is Z are mentioned, so we have to calculate again the y. Okay, admittance matrix we have to calculate. So I will convert this diagram into our admittance matrix, say y matrix. So point 2 is reciprocal is 5, here also 5. So I will, this is, we can say 0 or say ground, y11 y12 y21 y22 is equals to 5 plus 5. Now 1 2 is just a 5, 2 1 is 5 and 2 is 5, and non-diagonal elements are negative, so I can write as 10 minus 5 and 5. So option, check the option, 10 minus 5 minus 5 and 5, option is correct. I hope you understand now. We have solved multiple question on this. Next, a power system consists of two area via tie line. So we can say area 1 and area 2, and it is connected with a tie line, and connectivity of data inadvertently left out. If the load program is run with the incomplete data, the load flow calculation will converge only if. Now it is, option is about only slack buses. One means first area mentioned, second area mentioned, or say one slack bus is specified either in two areas, or whatever. The last option is about two slack buses in one area each specified. Now generally we know about V, P, Q and delta are mentioned at each buses or each buses in a system. But if we say slack bus, for this, if it is, we have say interconnected, no, this is slack for this one is different, and slack for this area is taken different. If we taken different, then only convergence is possible, otherwise all the losses will be go with each other, and this system means even if this system is fault, this system will go into a recovering that area, and in the recovery of that area, system A2 will also fail. So means that's why we will slack 1 and slack 2 consider for individual areas. So option D is correct. Here 2 slack buses, one in each area, are specified. Okay, I hope you understand. Thank you.